Hello there, we have moved on from binary search and into a linked list. We'll be doing reorder linked list. It will be using two of the concepts what we have learned before. This is number 52 of 150 Neetcodes. We'll be using a reverse linked list. That basically means we have to reverse the linked list. We also have to get to the middle of the linked list and split the linked list, and we have to merge the linked list in a specific order. Let's check out the problem. So in this particular problem, we are given the head of the singly linked list that can be represented like this, 1, 2, 3, 4, and we have to take the last item, put it in the second place, and then take the second last item and put it after the second item. So that's the order we need to do. So the way we're looking at this particular problem is that we're gonna go and cut this problem right in half, and we'll have two parts to this. We have this and that. Then we will reverse the linked list, so we have 4, starting at 4, and get to our midpoint, which is 3. And then we can insert the 4 after the first item, and then get our pointer to the second item, and our other pointer to this particular item, and point this one to that one, and eventually until the second is no longer exists, because this 3.next does not point to anything. Okay, and that's how we solve this particular problem. All right, so let's begin. Let's get to midpoint first. So midpoint is really easy to get. This is basically slow and fast pointers, and the method that I use, that I prefer, is while fast and fast.next and fast.next.next. It's the fewest lines of code, and it gets me what I want. It's slow equals slow.next, and fast equals fast.next.next. If you don't believe me, you've probably seen some of my videos before, but I'll show you again. 1, 2, 3, 4, and this is slow, this is fast. As you can see here, this makes it to this particular point, which is in the middle. And then we have a 1, 2, 3, 4, 5, and we have a slow. We have a fast in the same pointing spot. We go 2 this way, 1 this way, and we go 2 this way, and we go 1 this way, and we're in the middle again. And I'll show you one last time for the third time to get this to point across. 1, 2, 3, 4, 5, 6, and we have slow, we have fast, slow, fast, slow, fast, and we are in the middle again. So that's how we get the midpoint, and that is done. Okay, now we need to reverse the second part of our linked list. Reverse second half of a linked list. So that basically means first thing we need to do is make sure we get our midpoint, which is equal to slow.next. Then we're gonna set our previous item and slow.next to equal to none, because we don't want the 3 to point to anything anymore. So that means at this particular problem we had this pointer, right? And this points to that, and this points to that. We'll be using this as our example because we have written it out already. So this is slow, right? And this is fast over here, and slow.next is equal to 3. This is going to become our midpoint, and we're gonna stop pointing to 3 because we don't want this to obscure our information, because we don't want to run in a loop, and so we want this to end sometime soon. So we want to point this to none, right? Okay, so this is our midpoint at this point, and we need to reverse the linked list. So that means the simple way to reverse the linked list is, again, a very simple line of code. So while mid.next, what is that going to be? It's going to be previous. So we're going to set mid to previous, which is this one here. And I think we've done this before, but let's do it again. So previous is equal to, that's going to be equal to the mid, and mid is equal to mid.next. So, and that's how we reverse a linked list. So this code basically runs previous mid.next equals previous. Previous is equal to mid. So this becomes mid previous, right? and mid.next, mid is equal to mid.next, which was here. And so we move that there. Done. And this disappears, this particular linkage. This is temporary exists in the ether or something. Anyways, before we set mid.next equals prev. All right. So once again, we have previous. When we have mid, and then we we print we send it to previous, and we set previous to mid and mid to mid.next. Same thing, same old. And once we're mid is nil, we're done here. So this was pointing to none. So now it's no longer pointing to anything. Okay, with that, we are done here, and we can now get to the third part of our particular problem, which is to merge the two halves. So how do we do that? So we're going to have the two heads now, so first and second. And first and second, first is going to be equal to head, and second is going to be prev. So that basically means, let's wipe this out. We have this particular picture here now, and we have a first here, and we have a second here. So now, one thing we want to do is that, what the heck is that? While second, that means while this has something it's worth something, or pointing to something, we'll start moving. We can keep pointing. So first thing we're gonna do is we're gonna store this particular point at T1, and this is gonna be T2. We want to store these points so that when we start pointing to items to each other, we don't want to be pointing. We don't want to lose this item, because we're going to be shifting this particular 4 to this particular point after 1, which we're going to do right now. And so right, so we're gonna have to comment these a little bit so that we don't have these error things going on. So we have a while seconds, and there's some redness going on, so probably something bad. So let's see, T1 and T2 is equal to first dot next and second dot next. Once that is done, we can set first dot next to equal to second. So what this is going to do is going to move the 4 into our pointer here. So we're going to point to 4 instead of, and then we're going to point 4 to 2. So we're going to set second, first dot next is equal to second, and we're going to put second dot next is equal to T1, which was here, right? And then once that is done, we want to set first to T1, so we move this forward to here, and we move second back to T2, which is here, so that we can repeat the process. And so on and so forth. So then let's run through the code one more time. So T1 equals and T2 equals for T1 and T2. So T1 and T2 is here at none. And then we are going to first dot next is equal to 3. So we'll point that to 3, and 3 will point to T1, which is none, and first dot next and first dot second is going now to be equal to none and none, which is where T1 and T2 is at. And with that, we have completed our particular problem, because now second is now none, and we are done with this particular problem. So that is all. What is going on here? I don't know. But this is the code. And let's run it just to make sure we're on the right track. Run the code, and our code is accepted, and let's check the solution, and we are good to go. And that is how we do this particular problem. I think it's a great problem to do every now and then, because it comes up, these concepts come up over and over again for linked lists. This is getting the midpoint, reversing the linked list, and also merging two halves and just working with pointers. This is a good problem to do. I recommend it. There's a lot to learn here. and a lot of practice to have to visualize these items. I think the only way that I was able to, I'm going to be able to do this is to have visualizations and have this code out and have pointers pointing to things. Otherwise, it's really difficult for me to do. I can't visualize it without these visualizations here to keep me on track and to keep me going, to see that I'm placing the right item and I'm storing the right item and I'm sending the correct item is pointing to the correct item, and that's all that is. And I thank you very much. I hope you learned something today. If you have any questions, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.